Yes, namaste to all. Welcome to Disha online classes. So in the last video we discussed trigonometric equations. Okay. So in that trigonometric equation, principal solutions of the equation. Okay. And based on the principal solution, we seen some of the problems also. So today's class, let us start with the general solutions of the equation. Okay. So trigonometric equation have two types of solutions. One is principal solutions and general solutions. You already know what do you mean by exactly the principal solutions are. What are the principal solutions for a particular trigonometric equations. Okay. Before going to the general solution, there are three important theorems are there. Okay, they are particularly related to the sine function, cos and tan function. Okay, that means what are the general solutions. So what is the formula or expression to find the general solution of sine function as well as cos function as well as tan function. Okay, we'll see that. Yes, before going to that, to prove those theorems, we need some results. Okay, take down those results as a note point. So note 1, that is sine of x is equals to 0. Sine of x is equals to 0. That means for what values of x, sine x is equals to 0 means, so which implies x is equals to, it is an integral multiple of pi. That means a pi is multiplied with the integers. Okay, then x is your angle. If angle is equals to integral multiple of pi, then sine of n pi is equals to 0. Here n is an integer, belongs to the integer set. So similarly, second one, that is cos x is equals to 0. That means for what values of x, cos function is 0. So that is x is angle is odd multiple of, here 2n is a even number, 2n plus 1 is odd number, so odd multiple of pi by 2. Okay, where again n is belongs to the set of integer. That means here x is equals to pi by 2, that is 1 into pi by 2, 1 into pi by 2, that is cos of pi by 2 is 0. Here 2n plus 1 is odd. If suppose n is equals to 1, what will happen? 2 into 1, 2. 2 plus 1, 3. So that is 3 pi by 2. Okay, that means cos of pi by 2 is 0. Cos of 3 pi by 2 is also 0. Next, 2 to 4, that is 5 pi by 2. So cos of pi by 2 is 0. Cos of 7 pi by 2 is 0 and so on. Okay, yes. This is the general one. Similar to the sin x. Okay, and third one, that is tan function. So that is third one, tan function. Tan x is equals to 0. So for what values of x? Again x is equals to integral multiple of pi. Okay, tan x is equals to 0 for what values of x? Integral multiple of pi, that is tan pi 0, tan 2 pi 0, tan 3 pi and so on. Similar to the sine function. Sin pi is 0, sin 2 pi 0, sin 3 pi 0 and so on. Okay, these three are important. Just remember. Okay, here sin x is equals to 0 for what values of x, sine function is 0. So for integral multiple of pi, that is pi, 2 pi, 3 pi and so on. As well as minus pi, minus 2 pi and so on. Because n is an integer. Your negative values also there. Okay. Similar to second one, cos x is equals to 0 for what values of x? Cos function is 0 for integral value odd multiple of pi by 2. Here 2n plus 1 is a odd number. Okay. It may be a 1 pi by 2, 3 pi by 2, 5 pi by 2, 7 pi and so on. For all those angles, cos function takes a 0 value. Similar, lastly, that is tan function. So tan x is 0 for what values of x? That is integral multiple of. Okay, so sine and for tan angles are same. Okay, yes. Based on these, we will move to the general solutions. instead of here 0, if there is any other angle, another number, suppose 1, 1 by 2, 1 by root 2 and so on. So then what are the possible solutions, nature of solutions? Those are there are that. Okay, yes. So first one, theorem number 1, you reading theorem 1. Okay. So theorem number 1, so it's give the general solution of the sine function. Okay, yes. So statement is for any real numbers, x and y, for any real numbers x and y, if sine x is equals to sine y, for any real number x and y, if sine x is equals to sine y, then x is equals to n pi plus minus 1 to the power n into y. Okay, for any real number x and y, if sin x is equals to sin y, then x is equals to n pi plus minus 1 to the power n into y. Here x and y are real numbers. Here n is belongs to the set of integers. Okay, this is the statement. So what exactly we need to prove? We need to prove that if suppose sin x is equals to sin y, then we need to prove that x is equals to n pi plus minus 1 to the power n into y. So this is nothing but for a sine function, the general solution is x is equals to n pi plus minus 1 to the power n into y. Okay, yes. So write down proof. So in order to prove this statement, first we need to consider sin x is equals to sin. Okay, by using this condition sin x is equals to sin y, we need to prove that x is equals to n pi plus minus 1 to the power n into y. This is what exactly, if here then is there, na? If this is true, then this is true. This is the actual meaning. If this is this statement, sin x is equals to sin y, if this statement is true, then we need to prove that this statement is also true. Okay, so here we need to consider first sin x is equals to sin y. Yes. Let sin x is equals to sin y, or just take on instead of like if sin x is equals to sin y. See, I will write sin x is equals to sin y as sin x minus sin y, which is equals to 0. Okay, sin x minus sin y is equals to 0. And now use here sin c minus sin d formula. Correct? This is the sin of c minus sin of d. Sin c minus sin d is equals to 2 times of cos of c plus d by 2, that is cos of, here c is x plus y by 2 into sin of c minus d by 2, that is x minus y divided by 2 is equals to 0. Okay, use here sin c minus sin d, that is 2 times of cos of c plus d by 2 into sin of c minus d by 2 is equals to 0. And now 2 into cos function into sin function is equals to 0. That means a into b into c is equals to 0. That means either a is equals to 0 or b is equals to 0 or c is equals to 0. But here 2 is there, 2 is not equals to 0. So leave it. So remaining possibilities are either cos of x plus y by 2 is equal to 0 or sin of x minus y by 2 is equals to 0. This is the rule. Product of 3 numbers is equals to 0 means either one of them is equals to 0 or 3 may be 0 possibilities. Right now? Yes. So that here 2 is not equals to 0, so that I am taking So cos of x plus y by 2 equals to 0, or sine of x minus y by 2 is equals to c. Okay, C possibilities: either cos of x plus y by 2 is equals to 0, or sine of x minus y by 2 equal to 0. Then in the note point, that is second note, that is cos of x is equals to 0, then x equals to odd multiple of pi by 2. Is it clear? So odd integral of pi by 2. In the same way, here cos of, in place of x is here, x plus y by 2 is there. Correct? Na? So cos of this entire x is equals to 0 means x is equals to odd multiple of pi by 2. That means for what values of x plus y by 2 equals to, which is equals to 0 means, in place of here x plus y by 2, just to substitute odd multiple of pi by 2, then obviously we will get to 0. Correct? Na? So now this is of the form cos of x equals to 0. If cos of x is equals to 0, according to note number 2, that is x equals to 2n plus 1 into pi by 2. Here in place of x is angle x plus y by 2 is there. So that x plus y by 2 is equals to 2n plus 1 of pi by 2. Okay? This is because of note number 2 here. Or here, sine of x minus y by 2 equal to 0, note number 1, that is sine of x is equals to 0, then for what values of x? Sine function is 0, that is integral multiple of pi, that is n pi. So here in place of x minus y by 2 is there. So that sine of x is equals to 0, then here in place of x is x minus y by 2 is there, which is equals to n pi. Okay, these two because of note number 1 and 2. This is note number 1, this is note number 2, according to note number 1 and 2. Okay, yes. The next step is just simplification. Here 2 get cancelled. Okay, here 2 cancelled. So remaining x plus y is equals to 2n plus 1 into pi. So x plus y is equals to 2n plus 1 into pi. Okay, thereafter cancelling these two. And next here, x minus y is equals to, just cross multiply this two, take the right side, that is x minus y is equals to 2n pi. So or x minus y is equals to 2n pi. Okay, yes. Take plus y to that side. So here x is equals to, that is 2n plus 1 pi, plus y becomes minus 1. Here plus y there, take to right side. So then x is equals to 2n plus 1 pi minus 1. So similarly here or x is equals to 2n pi. So minus y becomes plus y after shifting to that side. Okay. So x is equals to 2n pi plus 1. Yes. See, here 2n, that is here n is a integer. Here n is a integer. See, n is a integer. So 2 times of n is a even number. 2 times of n is a even number. Okay, this is even. 2n is even. If suppose I add one number to that even number, then this 2n plus 1 is an odd number. Okay. So here minus is there. Correct? No? Minus is there. 1 minute. Yes. Minus 1 is there. Suppose assume that minus 1. So minus 1 to the power even number is, that is minus 1 to the power even is always plus, that is minus 1 to the power 2 again plus 1, minus 1 to the power 4 plus 1, minus 1 to the power even number is always equals to plus 1. So in generally minus 1 to the power 2n is equals to plus 1. Okay. Here minus 1 to the power 1 is minus 1. Minus 1 to the power 3 is minus 1. So minus 1 to the power 5, again minus. So in generally, minus 1 to the power odd number is 2n plus 1 is equals to minus 1. Okay, that means here minus sign is there. No? Minus is nothing but this is minus 1. Okay, this minus 1 can be written as minus 1 to the power 2n plus 1. Possibilities. So again here plus 1 into y is there. ಏನು ಇಲ್ಲ ಅಂದ್ರೆ 1 into y ಅಂತ. Okay, so ಹಾಗಾದ್ರೆ here 1 into y, 1 can be written as minus 1 to the power 2n. Okay, so here x is equals to 2n plus 1 pi as it is. So here plus of minus 1, correct? Plus of minus 1 to the power odd number. Minus 1 to the power odd number is again minus 1. So minus 1 into plus again minus. Okay, into y. Keep this pi as it is. Okay, here minus 1 is there. This minus 1 can be written as plus of minus 1 to the power 2n plus 1, because minus 1 to the power 2n plus 1 is minus 1. So plus into minus is minus. Similarly here, or x is equals to 2n pi plus minus 1 to the power 2n into y. Okay, similarly minus 1 to the power 2n into y. Minus 1 to the power even number is plus 1, so use 1 into 1. Okay, this is the important. Okay, yes. So here observe, here 2n plus 1 into pi. That means pi is multiplied with here odd number. 2n plus 1 is odd number. Here pi is multiplied with the even number 2n. Correct na? Here pi is multiplied with the odd number, even number. Here pi is multiplied with the odd number. So x is equals to, combining these two, I will combine these two results. Okay, here pi is multiplied with odd number. Here pi is multiplied with even number. So combiningly, pi is multiplied with both odd and even number. That means odd integers as well as even. Correct? So that x is equals to, combiningly x is equals to n pi. Combining these two results, x is equals to n pi, plus is there, written plus as it is. Here minus 1 to the power. Here minus 1 is raised to 2n plus 1. Here that is odd number, again here even number. So that in generally minus 1 to the power 2n. That means see, here x takes odd multiple of pi, here even multiple of pi. That means combiningly or taking union, so we will get pi is multiplied with both even and odd. Correct? Similarly, here minus 1 to the power odd, here minus 1 to the power even. So combiningly minus 1 to the power just n. Okay, minus 1 to the power n, that is a integer into y as is. Okay, so here n is a set of integers. Okay, so this point is very important. This is because of here pi is multiplied with odd number, here pi is multiplied with even number. So that means x takes both the values, odd multiple of pi as well as even multiple of pi. So that those values are actually integers. So in generally that is n into pi. Here n is integer. Similar to minus 1 to the power odd, minus 1 to the power even is, so minus 1 to the power combined, that is integers into. Okay, so this is our required result. Okay, that means if sin x is equals to sin y, then x is equals to n pi plus minus 1 to the power n into y. This is the general solution for the sine function, that is sin x is equals to sin y. Okay, yes, hence proved. This is very important. N belongs to the integer set. Okay, yes. Yes. This is for the sine function. That is a general solution of the sine function. Okay. So next theorem number 2 is there. That is for the cos function. Okay. Same statement. So write down. Theorem number 2. For any real number x and y, for any real number x and y, if cos x is equals to cos y, if cos x is equals to cos y, so we need to prove that x is equals to 2n pi plus or minus 1, where again n belongs to the set of integers. Okay. So here theorem number 2, here x and y are any real numbers. If cos x is equals to cos y, then x is equals to even multiple of pi plus or minus y, where n is an integer. Okay. Yes, let on proof. Yes. If, that means first we need to consider if cos x is equals to cos y. If cos x is equals to cos y, so I will write here cos of x minus cos of y, which is equals to 0. So cos x minus cos y is equals to 0. That means cos of c minus cos of d formula. So already you know cos c minus cos d is equals to, that is minus 2 times of sine of c plus d by 2, that is x plus y by 2 into sine of c minus d by 2, that is x minus y divided by 2 is equals to 0. Okay, so use here cos of c minus cos of d formula. So that is minus 2 times of sine of c plus d by 2. C is x, d is y, into sine of c minus d by 2. So that is x minus y by 2. Okay, so similarly here minus 2 is not equals to 0. So therefore possibilities are sine of x plus y by 2 equals to 0, or sine of x minus y by 2 equals to 0. Okay, either sine of x plus y by equal to 0 or sine of x minus y by is equals to 0. And again use here note number 1, that is sine of x is equals to sine of theta is equals to 0 for what values of theta, that is even integral multiple of pi. That means here in place of x is x plus y by 2 is there. So that sine of x plus y by 2 is equals to 0. That means x plus y divided by 2 is equals to integral multiple of pi. This is because of note number 1, that is sine x equals to 0, which implies x is equals to n pi. Here in place of x is x plus y by 2 is there. Or here sine of x minus y by 2 is equals to 0. Similarly, so this can be written as x minus y by 2, which is equals to n pi. Okay. Yes. The next step is just take this 2 to right side, that is x plus y is equals to 2n pi. Okay, x plus y is equals to 2n pi. Or here x minus y is equals to 2n pi. Okay, just cross multiply maadu. So ಏನಾಗುತ್ತೆ x plus y is equals to 2 times of n into pi ಆಗುತ್ತೆ. So here x minus y is equals to 2 times of n. So next x is equals to in terms of x. So x is equals to 2n pi. So plus 5 apply shift ಮಾಡಿದ್ರೆ that is minus 5. That is 2n pi minus 1. Or x is equals to 2n pi. So this will become plus 1. Okay. So again combining these two, 2n pi minus 1, here 2n pi plus 1. So combining these two, so combiningly above result, So what we will get, that is x is equals to 2n pi plus or minus y, where n is belongs to the set of integers. So hence proved. Okay, so this is about the cos function. So general solution of cos function, that is statement 2. Theorem number 2. If cos x is equals to cos y, then we need to prove that x is equals to 2n pi plus minus 1, 2n pi plus or minus 1. Okay. Yes. So first we need to consider cos x is equals to cos y and apply cos c minus cos b formula and simplify. And here use sin x is equals to 0. That is note number 1. If sin x is equals to 0, then x equals to integral multiple of pi. So similarly here also x minus y by 2 is equals to n by pi. And then simplify. So combining these two, that is here 2n pi minus y, here 2n pi plus 1. So combining it, that is plus or minus 1. Okay? Yes. This is about the cos function. So general solution of the cos function is, the formula is x is equals to 2n pi plus or minus 1. For sine function, n pi plus minus 1 to the power n into 1. Yes. So similarly, tan function, that's theorem number 3. Okay, general solution of a tan function. Yes. So for tan function, again there is a expression for the general solution. Okay, we need to prove that. Theorem number 3 statement. Write down. Again, for any real number x and y particularly. Okay, but here condition we are imposing on the x and y. I will tell why because. So theorem number 3. Let x and y are not odd multiple of pi by 2. Okay. Let x and y are not a odd multiple of pi by 2 if tan x is equals to tan y. If tan x is equals to tan y, then we need to prove that x is equals to n pi plus y. Here n is belongs to the set of integers. Okay. So here theorem number 3. Again similarly here x and y are real numbers, but particularly here x and y are not odd multiple of pi by 2. Why this is because of, tan function can be written as, so tan function is, that is sine divided by cos. Correct? Sine x divided by cos x. If suppose here x is odd multiple of pi by 2, that is if x is 1 into pi by 2, what will happen? So that is cos of 90 degree, cos 90 degree is 0. So here sin 90 is 1 by 0, not defined, that is infinity you are getting. Correct? Na? So avoid this. So we are imposing a condition, that is x and y are not a odd multiple of pi by 2. Similar to tan y, that is sin y by cos. Okay. So to avoid this indefiniteness, okay, so we are imposing a condition, that is x and y are not an odd multiple of pi by 2. So assume that we need to prove that tan x is equals to tan y, then x is equals to n pi plus y, where n is a integer. Yes, let us prove. If tan x is equals to tan y, tan x is equals to tan y, so tan function can be written as instead of tan function can be written as sin x divided by cos x. Here tan y can be written as sin y divided by cos y. Next, cross multiply, that is sin x into cos y, sin x into cos y. So equal to here cos x into sin. Okay. So here sin x by cos x because of tan function. Tan x is equals to sin theta by cos theta. So that here tan x is equals to sin x by cos x. Here tan y is equals to sin y by cos y. So similarly, after that just cross multiply to sin x into cos y and here cos x into sin. Then next take this cos x into cos y to left side, that is sin x into cos y, so minus cos x into sin is equals to 0. Okay, yes. Then see, this is looks like a formula, that is sin x into cos y minus cos x into sin y, compound angle formula. So sin of x minus y, sin of x minus y is equals to sin x into cos y minus cos x into sin y. So use that one here. So this total entirely can be written as sin of x minus y is equals to 0. Okay. Sin of x minus y is equals to 0. So now this is of the form, again sin x is equal to 0. Treat this x minus y completely as an x. So what is that is sin x is equals to 0. Note number 1. So if sin x is equals to 0, then x is equals to that is integral multiple of pi, that is n pi. Okay. So that here sin of x minus y is equals to 0. Sin of x minus y is equals to 0. So this can be written as x minus y is equals to n pi. This is because of note number 1. That is sin of x is equals to 0, then x equals to n pi. Here treat x as a x minus y. Right. So then x is equals to n pi as it is. Take minus y to that side, that is plus y. So x is equals to n pi plus y. Here n is the integer, which belongs to set of integers. Okay. So this is the required solution, general solution, which give the general solution for the tan function. Okay. This is for the general solution tan function. Okay. Yes. So then this right hence proof. So this is for the tan function. Okay. So first one is general solution of a sine function, cos function. Second one, that is third one, theorem number 3, that is here for the tan function. Okay. These three results are very important to solve the problems. Okay. Based on these results, we have the, some problems. Okay. We'll discuss it. Yes. Then next is the three theorems gives the general solutions of sine function, cos function and tan function. Okay. Based on these results, we will solve some more problems. Okay. Yes. Yeah. Yes. So before going to the problem, just take these results. Okay. That is just only we prove now. That is sin x is equals to sin y. So if sin x is equals to sin y, then general solution is x is equals to n pi plus minus 1 to the power n into y, where n belongs to the set of integers. Okay. Next, similarly for the cos function, cos x is equals to cos y, which implies, so x is equals to 2n pi plus or minus y, where n is belongs to the set of integers, where n is an integer. So third one is tan x is equals to tan y, then general solution x is equals to n pi plus y, where n is belongs to the set of integers. Okay, based on these three results we will solve the problems. Okay, that means finding the general solutions of a trigonometric equations. We know already how to find the principal solution. Okay, so similar to that, using these results we will solve problems, that is finding the general solutions of the trigonometric equations. Yes, so in that, write down first problem. So write down S. Find the general solution of, or find the solution or general solution, both are same. Okay, find the solution of a trigonometric equation sine x is equals to 1. Find the solution of trigonometric equation sine x is equals to 1. Okay, yes, solution. So given equation, that is sine x is equals to 1. So now sine x is equals to 1. So this can be written as 1 can be written as sine of pi by 2, because sine 90 degrees 1. So this is of the form sine x is equals to sine y. Correct, na? Sine x is equal to sine y. Here y is pi by 2. So if sine x is equal to sine y, then result is x equals to n pi plus minus 1 to the power n into 1. So that, so which implies x is equals to n pi plus minus 1 to the power n into y. Here y is pi by 2. Okay, this is because of the theorem number 1. Yeah, since theorem number 1. Okay, sine x is equal to sine y. Here y is pi by 2. If sine x is equals to sine y, general solution is x is equals to n pi plus minus 1 to the power n into pi by 2. This is the general solution of the equation sine x is equals to 1. That means here substitute, or you can take any values. Here n is an integer, 1, 2, 3, 0 and so on. Okay, so here n belongs to set of integers. Okay, yes, x equals to n pi plus minus 1 to the power n into pi by 2 is the general solution. General solution of the given trigonometric equation sine x is equals to. Okay, this is the way to solve or finding the general solution of the equation. That means we need to know the theorem 1, 2, 3. Okay, based on those theorems only, we need to write general solution. Yes, then next, second one. Find the general solution of cos x is equals to 1 by 2. Okay, find the general solution of cos x is equals to 1 by 2. Yes. So given trigonometric equation, that is cos x is equals to 1 by 2. So cos x, which is equals to 1 by 2, can be written as, in terms of cos, that is cos of 60 degrees 1 by 2, correct? So cos of pi divided by 3. And now this is of the form cos x is equal to cos y. So if cos x is equal to cos y, then x is equals to 2n pi plus or minus y. Here y is pi by 3. So since here n belongs to the set of integers, since theorem number 2, by the theorem number 2. Okay, the theorem number 2 is, that is cos x is equal to cos y. If cos x is equal to cos y, then x is equals to 2n pi plus or minus y. Here y is, that is pi by 3. Okay, yes. So next, question number 3. solve sin x is equals to minus root 3 divided by 2. Solve means find the values of x. So finding the value of x is nothing but finding the general solution. Okay. So that here given sin x is equals to minus root 3 by 2. So solution sin of x is equals to root 3 minus root 3 by 2 is there. So first consider plus root 3 by 2. Okay, first consider plus root 3 by 2. Okay, yeah, of course question is in terms of negative, that is sin of x equals to minus root 3 by 2. But initially consider sin x is equals to plus root 3 by 2. Okay, and then now here sin x is equals to this root 3 by 2 in terms of sin function of how to write, that is sin of 60 degree. Correct? Sin 60 degree root 3 by 2. That is sin of pi by 3. Now see, sin x is equals to sin y. Don't use. If you use here sin x is equals to sin y result, that means you are finding the general solution for sin x equals to plus root 3 by 2. But here our aim is to find this general solution of sin x equals to minus root 3 by 2. So that here x is equals to pi by 3. Just take x is equals to pi by 3. Okay. Then next, come to this point. Here sin function is negative is there. That means sin x taking negative value, that is minus root 3 by 2. So sin function is negative in which quadrant? It is in the second, that is in your third quadrant and in fourth quadrant. Correct? Sin function is negative in third as well as in fourth quadrant. So I am writing sin of third quadrant means that is pi plus theta. Pi plus theta. So use here in place of theta this angle pi by 3. So pi plus pi by 3, which is equals to sin of pi plus pi by 3, that is sin 180 plus theta is 180 plus theta third quadrant. In third quadrant sin function is negative, so minus. So sin 180 plus theta is sin theta, that is sin of pi by 3. Here theta is pi by 3. Okay, up to here, okay, up to here is clear. So after that, observe the question. Sin function is negative is there. In which quadrant sin function is negative? In third as well as fourth. Okay, so take that third quadrant first. So sin third quadrant means pi plus theta. Pi minus is in second quadrant. In second, sin function is positive. So your negative sign is there. So take sin, that is pi plus theta. Take your theta as this angle, pi by 3. So sin of pi plus pi by 3, which is equals to, by using allied angles, sin of 180 plus theta is minus sin theta. So minus sin pi by 3. So equals to minus sin of pi by 3. See, sin of pi by 3. Sin of pi by 3 value, that is again minus root 3, sorry, plus root 3 by 2. So this is sin of pi plus pi by 3 is, that is 4 pi by 3. Okay, so see, observe here, sin x is equals to sin pi by 3, here minus sin of pi by 3. So general solution, how to write general solution? Sin x is equals to sin y. Here y is actually, that is 4 pi by 3. Because minus root 3 by 2 is equals to sin of 4 pi by 3. In question, sin x is equals to minus root 3 by 2 is there. So in place of minus root 3 by 2, I will write sin of 4 pi by 3. Okay, so that means, wait a minute, yes, sin of 4 pi by 3 or so that is given equation, given sin x is equals to minus root 3 by 2, okay, which is equals to this minus root 3 by 2 can be replaced by sin of 4 pi by 3. So sin of 4 pi by 3, okay. So sin of x is equals to sin of 4 pi by 3. So minus root 3 by 2 is sine of 4 pi by 3. This is because of this. Okay, yes. So now observe, this is of the form sine x is equals to sine y. Okay, this is of the form sine x is equal to sine y. So if sine x is equals to sine y, then x is equals to n pi plus minus 1 to the power n into y. Here y is 4 pi by 3, where n belongs to z. Is general solution of given equation, that is sin x is equals to minus root 3 by 2. Okay, so here given equation sin x equals to minus root 3 by 2 is there. First take positive way, that means finding the x value. Then use allied angle concept, that means in which quadrant this function is negative in second and fourth quadrant. First use second quadrant. So in second quadrant, how to write 180 plus theta? Use that theta as this pi by 3 and equals to, by using allied angle concept, sin 180 plus theta minus sin theta. So minus as it is sin 60 degree, that is root 3 by 2, and this pi plus pi by 3 is 4 pi by 3. And the next is given is sin x equals to minus root 3 by 2. So this here minus root 3 by 2 can be written as sin of 4 pi by 3. Okay, here. And use here sin x is equals to sin y result. Okay. And next one is question number 4. Yes. Solve the equation or find the general solution. Find the general solution for the equation cos of 4x is equals to cos of 2x. Cos of 4x is equals to cos of 2x. Yes. See, observe here, given question is cos of 4x is equals to cos of 2x. Equation is cos of 4x equals to cos of 2x, right now? So now this is of the form directly cos x is equals to cos y. So directly use that result. So cos of 4x, which is equals to cos of 2x. So now this is of the form cos x is equals to cos y, that means cos x is equals to cos y, so which implies x is equals to 2n pi plus or minus 1, where n belongs to the set of integers. Here cos of x is 4x, cos of y is 2x. So that means cos of 4x is equals to cos of 2x can be written as x is equals to, that is 4x is equals to 2n pi plus or minus, in place of y is 2x. So again here n belongs to the set of integers. So just to simplify this, here two possibilities are, one is plus and another one is minus. So this can be written as 4x is equals to 2n pi plus 2x, or so next 4x is equals to 2n pi minus 2x. Okay, first consider plus positive part and negative, and take this plus 2x to this side. So what you will get, that is 4x minus 2x is equals to 2n pi, or here 4x, so after taking minus 2x to this side, that is plus 2x, which is equals to 2n, here 4x minus 2x, that is 2x, is equals to 2n pi, or 4x plus 2x, that is 6x, is equals to 2n. Okay, yes, here 2 get cancelled, so then x is equals to n pi, or here x is equals to 2n pi divided by 6. 2n pi divided by 6 is x is equals to, that is n pi divided by 3. So take this 6 to this side, that is 2n pi divided by 6. So 2 ones are 2, 3. So n pi by 3. So these two are the solutions. So x is equals to n pi or x is equals to n pi by 3. These two are the solutions of the equation cos 4x is equals to 2x. General solutions. Okay. Here write down again. Are the general solutions of the given trigonometric equations are the general solution. Okay. This is all about the finding the general solutions of the trigonometric equations. Okay. So we'll discuss some more problems in the next class. Okay. So before going to that, take some more homework problems. Yes. Yes. So question homework problems. Find the solutions. Find the solutions of following trigonometric equations. Okay. So first one, cos of 6x is equals to cos of 4x. Okay. Next one, sine of 2x which is equals to sine of 4x. Fourth one, sine x is equals to 1 divided by 2. Cos x is equals to root 3 divided by 2. Fourth one, tan x is equals to 1. Yes, tan x is equals to 1. And fifth one, cos of x is equals to minus 1 by root 2. And sine of x is equals to minus 1. Next, seventh one, tan x is equals to minus root 3. Okay, solve these 7 problems. Okay, these problems are home. Do it, and we will discuss some more problems based on solutions or trigonometric solutions. Okay, yes, thank you all. Thank you.